Group 3 Laboratory Report. Research Analysis Techniques. Biogenic amines in meat and meat products. A review of the science and future perspectives.
Background of the study: biogenic amines, or BS, are nitrogenous compounds formed primarily by the microbial decarbonylation of amino acids during food fermentation, processing, and storage. In meat and meat products, they are particularly concerned due to their potential toxicological effects, including allergic reaction, histamine poisoning, and foodborne illness outbreaks. The accumulation of BS can be influenced by several factors, such as microbial contamination, temperature, pH, and product composition. As a result, effective detection, monitoring, and control of BS are crucial for ensuring food safety and consumer health. Research Analysis Techniques. In this review article, the author discussed the following research techniques used in the analysis of biogenic amines in meat and meat products.
Gas chromatography, or GC, another widely used method, often coupled with derivation to enhance the detection of volatile amines. Thin layer chromatography, or TLC, used for qualitative and semi-quantitative detection for bioamines, although less sensitive than HPLC or GC. Number 2. Spectrum photometric method. Techniques such as fluorescence and UV visible spectroscopy can be used to detect bioamines indirectly after derivatization. These methods are less precise than chromatographic techniques, but are more cost-effective and easier to implement in routine food testing.
Enzymatic assays. Enzymatic kits are available for detecting specific species such as histamine by using enzymes that catalyze the oxidation of BS. These assays are less than sensitive than chromatographic methods, but are useful for rapid screening purposes. Mass spectrometry. Coupled with chromatographic techniques, HPLC, MC, or GSMS, mass spectrometry allows for more accurate detection and identification of BS even at very low concentration. It is considered a gold standard for the identification and quantification of BS in food sample.
Microbial testing. Testing for the presence of BA-producing bacteria, e.g. certain strains of Enterobacteriaceae or Lactobacillus, is another important part of the research in BAs in meat products. Molecular methods such as PCR polymerase chain reaction are used to identify BA-producing genes and microbial communities.
If you are analyzing biogenic amines in fermented sausage, you would first extract the amines from the sample using solvent. Then HPLC could be used to separate and quantify BS such as histamine, tyramine, and putrescine. This allows food scientists to monitor BE levels during production and adjust processing parameters to reduce their permission. 2. Spectrophotometric methods. These methods rely on measuring the absorbance or fluorescence of BE derivatives in UV or visible range. Derivatization is needed to enhance sensitivity. In routine quality control, a spectrophotometric method might be employed as a rapid, cost-effective screening test for histamine in canned meats, ensuring levels do not exceed regulatory threshold.
Assays. Explanation. This assays use enzymatic that works especially with the certain biogenic amines producing a measurable product that correlates with BA concentration. Application: A meat processing company could use an enzymatic assay kit to screen raw materials for histamine before they process into usage. This would help to injecting batches with the high BA content early in the product chain. For mass spectrometry explanation, mass spectrometry provides detailed information on the mass and structure of molecules, allowing for highly sensitive and accurate identification of mass application. When deals with the complex meat products, MS coupled with the GC and HPLC can be used of advanced research regulatory processes to detect trace amount of harmful gas. This is useful in the end food safety labs where precise measurement of the toxic amines are crucial regulatory compliance.
There is a need for more consistent regulatory limits across countries as current legislation varies and is often inadequate for comprehensive consumer protection.
To summarize, the article discusses a variety of analytical techniques, ranging from highly sensitive chromatographic and mass spectrometric methods to more accessible enzymatic and spectrophotometric assay. Each method has its own strengths and is suited to different application, from routine testing in production settings to detailed research in food safety laboratories. The application of these techniques enables producers and regulators to monitor, control, and minimize the presence of BS in meat products, ensuring consumer safety.